Welcome to Siledge Academy. In this video, we'll be talking about indices. All you have to know about indices and the laws of indices, most importantly. Now, what is indices? I don't know if you've heard of the word index. When you have numbers like this, 2 times 2 times 2 times 2, this number can be expressed in index form. Expressing in index form, you have 1, 2, 3, 4 2's here. So this is equal to 2 raised to the power 4. So it's in index form, like this. Now, when you have two numbers adding or subtracting themselves, two numbers in index form adding or subtracting themselves, or multiplying or dividing themselves, how do you solve them? That is where this law of indices comes to play. Okay, so yeah, that's what we're talking about. You just can't solve questions in indices like that. That's why this law of indices is very, very important to us. Now, let's look at the laws of indices. The laws of indices will guide us in solving questions in index form. The first law we have here is multiplication law. We call that the multiplication law, where you have a raised to the power m times a raised to the power n. This will give you a raised to the power m plus n. So you just pick one of the bases here, and you add up the powers. Okay, let's go. So we have an example. This is just how it is here. Now let's solve an example. What we'll be doing here is we'll pick out each law, we solve an example under it, so it will help us understand it better. Now look at this example. We have number 1 here. This one says 2. So you have 2 raised to the power 8 times 2 raised to the power 5. This is very simple. You bring out one of the 2's here. This will give you 2 raised to the power 8 plus 5. And this is equal to 8 plus 5 will give us 13. This is equal to 2 raised to the power 13. This is our final answer. Another example here, where you have something like 5 raised to the power 3 times 5 raised to the power minus 2. This will give you, you pick out the 5 raised to the power 3 plus minus 2. I see it now. So 3 plus minus 2 plus sign times the minus sign will give you a minus. So you have 5 raised to the power 3 minus 2, and 5 raised to the power 3 minus 2 will give you 5 raised to the power 1. 5 raised to the power 1 is same as just 5. We'll still get to the law that explains this. Let's look at the second law. So this is the first law, law number 1. Let's look at the second law, law number 2. This is called the division law, where the division sign is involved. The second law here, as you can see, this is law number 2. You have a raised to the power m divided by a raised to the power n. This is equal to, you bring out the base here, bring out the base, which is a, because they have similar bases. What we are solving here now is problems that have similar bases but different powers. Now, if you look at this, they have similar, we bring out one of the bases. This is similar to what we did in the first law, in the multiplication law. Because then the powers we subtract. You have m minus n. That's how this one works. Let's have an example under this. Something an example under this. Say we have 5 raised to the power 7 divided by 5 raised to the power 4. This is simply equal to 5 raised to the power 7 minus 4. And this will give you 5 raised to the power 3. That's it. Now, this question comes in another form. You might have something like this. Y raised to the power 9. This sign also means division sign. So when the question appears in this form, don't worry, just solve it the same way you solve this first one. So you have 5 raised to the power y raised to the power 9 divided by y raised to the power 3. This is still the same as y raised to the power 9 divided by y raised to the power 3. Then solving this, you just apply the second law here, which is y raised to the power 9 minus 3. And this is equal to y raised to the power 9 minus 3 will give us 6, y raised to the power 6. So this is our final answer. Are we good? So that is the second law. Let's move to the third law here. The third law here says, law number 3, it says, when you have something like this, a raised to the power m multiplied by a multiplied by n. So this is called the power law. Okay, power law. That's what we call it here. This law says that when you have double power, like more than one power, as you can see, a has a power and the both of them have another power. What you will just do here is very simple. you do the powers will multiply themselves. Just like in this case where the powers add, here the powers subtract. In this case, the power multiply. So you have a raised to the power m times n. Now I'll give you a question. You can always pause the video to try these questions yourself. Try them out. Here you have what? You have 7 raised to the power 3 times or raised to the power 5. You can pause the video and try this on your own. I always encourage that. So in case when you fail, you now take correction when I'm solving. This is same as saying 7 raised to the power 3 times 5. So the powers will multiply. 3 times 5 will give you 7 raised to the power 15. And this is it. Now you can try this out yourself. Then you have 14 raised to the power 2 all to the power 7. Now this is equal to 14 raised to the power 2 times 7. And this is equal to 14 raised to the power 14. So it's very, very simple. Now let's move over to the fourth law that we have here. Okay, this is the fourth law. The fourth law here says, number 4, it says any number raised to the power 1 is equal to that number. Any number raised to the power 1 is that number. Okay, what we mean is you just say have a raised to the power 1, because when you have a raised to the power 2, it means a times a. So that's a into 2 places. When you have a raised to the power 1, is just a on its own. So no matter how big or small the number is, if it's raised to the power 1, it's also equal to that number. That's it. So for example, you have 100 raised to the power 1. This is same as 100. That's it. Don't stress yourself too much. Let's now move to the fifth law, law number 5. This is the zero index law. And this law says that any number raised to the power 0 is equal to 1. Any number raised to the power 0 is equal to 1. How did we get this law? So for example, you have a raised to the power 0 is still the same as saying a raised to the power 3 minus 3. Because 3 minus 3 is 0, of course, right? Now, a raised to the power 3 minus 3, according to the second law of indices here, when the powers subtract, it is the same as saying a raised to the power 3 divided by a raised to the power 3. If you use the division law here, this second law, to solve this, you get a raised to the power 3 minus 3, right? Now, a raised to the power 3 is the same as saying a times a times a divided by, you also have a raised to the power 3 as the denominator, a times a times a. The a's will cancel out, a cancel out, a cancel out, a cancel out, a cancel out. So this is equal to, when they all cancel out, is equal to 1. That's why a raised to the power 0 is equal to 1. Very, very light and simple. Now we have law number 6. Law number 6 is your negative power or negative index law. This is number 6 here. You have a raised to the power negative n. When you have a number like this, a raised to the power negative n, then a raised to the power negative n can be written as 1 over a raised to the power positive n. Okay, it can be written as 1 over a raised to the power positive n. So the positive of the power, so the power will now have a positive sign here. Okay, so that's it. Let's have an example under this. For law number 6, when you have, for example, you have 4 raised to the power minus 2. You have to simplify this. 4 raised to the power minus 2 is the same as saying 1 over 4 raised to the power 2. Now the negative sign will no longer be there because it's now the denominator. 1 over 4 raised to the power 2. This is equal to 1 over 4 raised to the power 2 is 16. So it's equal to 1 over 16. Very, very simple. Now we have another question here. 5. So you can simplify this. 5 raised to the power minus 3. You can always pause the video and try this out yourself on your own. And please remember, if you remember to always like this video, so that it helps the algorithm know that we know what we are doing here and our video is actually being impactful. And also please do well to subscribe to this channel as that's the only way you can support us and to encourage us to continue what we are doing here. And also do well to share this video to your friends or anyone this video might be very helpful to. Thank you. Now you have 5 raised per minus 3. 5 raised per minus 3 can be written as 1 over 5 raised per positive 3. And this is equal to 1 over 5 raised per 3. 5 times 5 is 25. 25 times 5 is 125. So 5 raised per 3 is 125. So this is our final answer. So for the 7th law, we have fractional index law. This is a unit fraction, fractional index law. That's what we call it, where the power has a fraction, where the power is a fraction. So you have a raised to power 1 over n. So the power is a fraction. In this case, it's going to give you the nth root. The nth root of the base. That's raised to power a. Right? That's what it will give you according to the law of indices. Let's have an example under this. For example, you have to simplify this. 25 raised to power 1 over 2. This is equal to, you have the square root. This is the nth root here. So it's the square root of 25. And the square root of 25 is 5. So this is our final answer. Let's have another example. You have 27 raised to power 1 over 3. This is equal to the nth root, which is 3. Okay, that's going to be our cube. That's going to be the cube root of 27. The cube root of 27 is 3. So that's equal to 3. Can you say it now? So it's going to be the denominator of the fraction root. So the roots will be gotten from the denominator of the fraction. Are we good? Then we have number 8. Law number 8. Law number 8 is a general fraction index law. Remember, this one is a unit fraction. Law number 8 is a general fraction index law. Here you have a raised to power m over n. So the numerator, we have a value in this situation. Okay, the numerator, we have a value. Now this is equal to the nth root as well, just like we did in the 7th law. It's going to be the nth root of a, all of them raised to power m. So the denominator roots raised to power of the base raised to power the numerator. That's what it's going to be. Let's have an example under this. We have 16 raised to power 3 over 4. Now this is equal to the 4th root of 16. The 4th root of 16 raised to power 3. Now, what's the 4th root of 16? So the 4th root of 16 is 2. Right? So the 4th root of 16, by now you should know how to find square root and square root, cube root, and 3rd root and 4th root, whatever. You should know how to find that. If you don't know how to find that, I'll make a video on that so to help you understand this better. Now, the 4th root of 16, you can punch it in your calculator. If you have your calculator, you punch it in your calculator. The 4th root of 16 is 2. So that's going to be 2 raised to power 3. And 2 raised to power 3 is equal to 8. So that's it. For the 9th law, a raised to power n times b raised to power n. Now, this is same as saying a times b, because this case now, the powers are the same. They have the same power here, but they have different bases. So the power is simply ab raised to power the base here, which is n. So that's it. A raised to power m, a times b raised to power n. Let's have an example under this. For example, you have 3x raised to power 4. This is equal to, everything in this bracket is carrying this 4 here. You understand? Everything in this bracket is raised to power this 4 here. So we are going to split the 4. This is the same as saying 3 raised to power 4 times x raised to power 4. Now 3 raised to the power 4 is equal, so this is equal to 3 raised to the power 4 is 81. Then x raised to the power 4 is x raised to the power 4. So this is our final answer. It can also come in division form. For this, you have something like a raised to the power n divided by b raised to the power n. So they both have the same power but different bases. So this is equal to a over b, or b, all raised to the power n. This is it. Let's have an example in this form. So for example, you have 2 over 5, 2 over 5, all raised to the power 3. Now this is equal to, everything here we carry the power. This is equal to 2 over 2 raised to the power 3. It's not supposed to be in the bracket. Now this is equal to 2 raised to the power 3 over 5 raised to the power 3. Everything in the bracket we carry this power. This is equal to 2 raised to the power 3, 2 times 2, 4, 4 times 2, 8. So it will be 8 divided by 5 raised to the power 3, 5 times 5, 25, 25 times 5 is 125. So this 8 over 125. Please support us by liking this video. If you have any question or any complication, do well to write it down on the comment section, or reach out to me on my email that is on this screen, or also on my WhatsApp number. Just text me. You'll be able to reach out to me there, so we can help you become the best version of yourself when it comes to mathematics. Okay, now in our next video we'll be solving more questions using all the laws of indices. This is just to introduce the law to us. In our next video we'll be solving questions using all these laws, how they can be applicable in solving questions that in index form. Okay, see you in the next video. Peace.